Welcome again, and this video is in continuation with the previous video. And here we are discussing the silicon, which is a semiconductor. And for semiconductor, the story changes. So here the 1s2, 2s2, 2p6, 3s2, 3p2. This is the electronic configuration, and we have the energy levels. And when we have silicon crystal, 3s and 3p get mixed up each other, and they call it sp3 orbital, sp3 hybridization. And when there is a covalent bonding between the atoms of the silicon, and here the sp3 hybridization takes place. So there is a sp3 hybridization takes place, and the energy level completely changes. So these two, 3s and 3p, merge together by the sp3 hybridization. And you can see here the valence band and conduction band. So this 3s and 3p, which both contain the 8n. Here we have 8n states, 2 for this 3s and 6 for this 3p. So these quantum states will have different energy levels. All these quantum states have different energy level, and they will form the valence band and conduction band. So which we can see in the next slide. Here you can see the valence band full of electrons. All those electrons are associated with their parent atom. And conduction band is almost empty. And but we are discussing this situation at a very low temperature. This conduction band is empty, almost temperature equal to very low, means less than 0 degree Celsius, or you can say T equal to 0. I am talking the capital T, not degree Celsius. T equal to 0 Kelvin. So there will not be any electron. There will not be any electron for the conduction. There won't be any electron. Okay, so then it will behave as a insulator. Okay, but and we know that temperature is not practically possible, and practically we do things on the temperature of 300 Kelvin, and that temperature will impart sufficient energy so that some of the electrons from this valence band can jump into the conduction band. So because this conduction band will have empty quantum states, and these electron can jump, to the conduction band. And when these electrons are in this conduction band, then these electrons can respond to any electric field. And how these bands are forming? The energy of 3s and 3p are redistributing, and this is how we are forming the band. Okay, so this is how the band forms inside the solids. Okay, what is conduction band? Lowest energy band which is not completely filled. What is valence band? Highest energy band which is completely filled. Okay, lowest energy band which is not completely filled is called the conduction band. And what is valence band? Highest energy band which is completely filled. So the because here we are talking about 3s 3p. Above 3s and 3p there are 3d also, which is also completely empty. For the silicon atom, which is completely empty, 3d is also there. And before 3d the 4s will be there, because the energy distribution is different. So the 3d 4s will be there actually, and then 3d. So these all are empty. Okay, so here, that is why I am saying the lowest energy band which is not completely filled is the conduction band, and the highest energy band which is completely filled is the valence band. Okay, so this is the band theory of solids. Actually, I know this is quite complex for you, and one thing that you need to understand when we are talking about these quantum phenomena, that electron takes energy and jumps, and the electron takes energy in the finite steps. These all things are gross approximation. Actually, these all are approximation, and actually we are just describing these behaviors according to the quantum mechanics, and there are some equations, and the mathematical things are there. So which are not in our syllabus. So actually the thing is this: we need to understand these things qualitatively, not quantitatively. So I think this is the explanation in which I have not used any equation. I have given you the explanation on the basis of the transition and the interaction between atoms and these energy level changes. And for all this you must have a some background in the chemistry, in the basic chemistry, atomic structure, what is this 1s, 2s, 3s, shells, number of shells, orbitals, and number, and why I am saying 6p6. So if you are not aware of this thing, then this explanation might be a problem for you. But if you are well equipped with the basic chemistry, then you can understand it very easily. Okay, so now we shall move to the next slide. Next slide is the summary of